Hi, E111. This is Professor Snell. I was talking to a group. They were asking me about what kind of light readings they should be producing for their project. And through talking with them, I realized maybe we didn't cover this enough. And so I decided just to answer their question with a video for everyone. The first point is just to remind ourselves that our photocell is a variable resistor. Um, we've been using it in this voltage divider circuit. So basically, the idea is that we apply 5 volts to one side of what's called a pull down resistor of a known value. Um, the other side of that we connect to the one pole of our photocell. The other side of that we connect to 5 volts. And the place where the two resistors come together, we pull off of that to get a variable voltage based on how much light is hitting the photocell. Um, and that's called a voltage divider circuit. And if you go into what is this? This is week 8, the week 8 lecture slides. Down at the bottom, there's a bunch of slides describing this and how we got the equation that we got or that we were using. It's interesting and not that complicated. But the fact is that we don't actually need the resistance values. This is a chart that's in another one of your slide decks um, where we're starting with voltage and we're ending up with lux, which I'll talk about in a second. And we get there by going through um, the variable resistance measurements that are defined by that equation. But we can also just skip the resistance equation and go from voltage directly to lux or voltage directly to descriptive terms like these here. In some ways, that makes more sense to me because, as I said, these photocells are not. Let me find yeah, they're not very sensitive. So or I don't know if I said that or not yet. This chart right here um, is an output of the response that a photocell like the one that we are using produces, and we can see that it's a pretty small range of wavelengths of in the visible spectrum, and that there's a very sharp peak to which wavelength, the response to wavelengths. So it's more like an on-off type of sensor or a um, cloudy day, bright day type of sensor. Um, and in our circuit, though, so it's not that accurate. The circuit we're using, we're outputting volts. So we have a VCC, which is the input voltage, and we have a VO, which is the output voltage. So regardless of its sensitivity, volts is not a measurement that anyone can understand in terms of light levels. So we need to either convert the volts to lux or to some other descriptive term like cloudy day, sunny day. So let's just talk about lux for a second. You can go read the technical definition of luminous flux, which is what lux is measuring. But the simple way of thinking about it is that it's the amount of light incident that's falling on a surface. And so in our case, this surface is the top of our photocell. Um, the thing with lux is lux is an absolute measurement. So it's clear to somebody if you say that's 10 lux, they have some idea if they know about illumination how bright that is. Um, Thing is, it's very accurate, and so in a way, converting from our voltage measurement to lux is a little bit disingenuous because it makes it seem like we're able to be more accurate than we are, but it's fine, and you can do that if you like. Um, and I think you need to do that just as part of the assignments, but then we could go from that measurement, either the voltage or the lux, to those descriptive terms, and that's what I'm talking about, showing you how to do today in this little video. Um, so let's go to Excel. Um, what I've done here is by the way, I'm going to go turn off this stuff just to show you. I made a little modeler or a converter in Excel. I can even turn this off for a second. When I use Excel, I try to create outputs that are something like this that look kind of like a physical, um, piece of hardware. So If you want to know how to do this, I can show you. It's pretty simple, but that's not the point of this. The point is just to get. This is just I'm trying to make this clear, so that this is a visual tool for me to show you how to get from voltage to lux. Um, so just remember that you may want to do this for your report, and you may want to use this in your oral report even. But what I'm talking about here is how to output data or publish data, light data to the broker. So this is just a stand-in for that. Anyway, so this is a version of an assignment you did, and the idea was that you were supposed to use that assignment to as a as inputs to your project. So you had 5 locations that you were supposed to scout out that had different levels of light that maybe you could even describe from your impressions of them, but they needed to be very different just so that we could get a range. And so by the way, I made these up. These are kind of from this chart, but not really. I started with point one and I did a point one, but I just literally made them up. So you should not use these. If I see this exact setup in your report, I'll know you just copied it from me and that it has nothing to do with any real measurements. Maybe we should say right now that I would suggest that when you're doing this, if you haven't done it yet, that you do it in the place you're going to deploy your system. So if you're going to do it in an office, then pick something that's like an office so that turn on and off lights and have a desk lamp that you can put in front of it so that it's fairly bright, and then have an overhead light, and then maybe be able to turn the lights off. And then you can create descriptive terms based on those settings, or if you were, or those different levels of light, or if you were going to put this in your window in your dorm room, and you wanted to be able to keep track of actual light outside, like so sunrise. If it gets direct sun, that would be one of the measurements. A cloudy day, whatever. And that's what I've done here as this little example. Okay, so we found a location. The idea was that then we'd make 2 measurements. The lux measurement we're making with an app that you downloaded free. There's tons of them for your smartphone. And you stood there in the light level in the place that you're calling location 1, and you said, okay, my app on my phone says what? Oh, it's 0.1 lux. Okay, I'm going to write that down, put that in my chart. Now and at the same time, I have my photocell voltage divider circuit that we're using in our sensor network, and you're measuring the light levels there and getting a voltage output. So in this case, it was also 0.1. So I typed those 2 in. Great. Then I went to the next location, which again, I'm making up. These are not real locations, but this is just an example. In that location, I had a lux reading of 1 and a voltage reading of 0.5. I went to the next location. I got a lux reading of 10 and a voltage reading of 1. You'll notice that this is just a logarithmic scale. Lux is a logarithmic unit, or it's expressed logarithmically. So anyway, the point is that I have 5 data points, or I have 5 locations with a voltage and lux measurement for each. And I went ahead and I made up some descriptive terms that I thought were based on my subjective feeling or impression when I was in those spaces, how they would translate. Then, so what do I do with that information? Well, and this is where you would actually use Excel. Okay, and so it doesn't have to be this nice, but it should be. Why not? And I can, it's easy to learn how to do this. But here's the idea. And I'll show you. I'm going to let me make sure let me go ahead and show. Let's see. Trying to turn on some stuff here. Formula settings, grid line, and I'll go ahead and. So now we're back to something that looks kind of like you're used to in Excel if you have ever used Excel. Okay, so the first thing you would want to do is make this chart and then make this table and then create a chart like this one here. The way you do that is go to Insert, Charts. I would insert a scatter plot, and I'm just going to set it right here on top of this other one. And we're going to need to bring in data to this chart. So if I right-click on the chart and I go to Select Data, and I'm going to call this, I'm going to add a data series, and I'm going to call it um, volts to lux. My x value, which is going to be, the x-axis is going to be the volts that I got in my experiment, and the y value is going to be the lux. And now you can see that we have that same data that I have in my chart, right? I've just configured this, I've added axes, easy to do, axis titles, chart title, a legend, whatever you want to add. And again, we can talk about that if you, or just there's plenty of tutorials on Excel. That's how I learn Excel, is just looking it up and playing around. Anyway, so here I am in my original chart. I'm going to delete this equation, this trend line here, just to show you how to make it. Okay, so here's my data set in a scatter plot. And by the way, change chart type. Scatter plot just with the points. Don't put any curves on it. Okay. So and you can change these at any time you want. These chart types by right-clicking and picking change chart type. So if I select my data set and right-click on it, I can add a trend line. And a trend line is just an equation applied to a set of data, trying to fit a curve to the data mathematically. And so I could try, there's these different presets in Excel. Exponential is not too bad. Linear is bad. Power, doesn't really not very good. I picked polynomial because it's just, it's creating a pretty accurate for obvious reasons, it's creating a pretty accurate equation or fit for a trend line. Then I can come over here and select display equation and chart. And now I have an equation here in my chart of this line. And what is it doing? It's relating y to x, right? And so y is my lux values and x is my volts, or my voltage values. So I can now take this equation and create a little calculator. And so I'm going to do this in Excel just to show it to you, but this is the equation, not this one, but the equivalent equation for your data that you would use in your Arduino sketch to do the same thing I'm doing here. But let me just show you how it works. So in Excel, I've created an equation here. Equals is how you start an equation in Excel in a cell. So I'm up here. I did an absolute value, so ABS. And then I just put in this equation. V, by the way, let me just show you. I named this cell V, so you can see if that's a V. To name a cell, I right-click on it. Let's say I was naming this cell and go to define name, and then I can put whatever I want to call it in there. That's just a way of making these equations simpler. So every time I type in V now, that cell is called upon or is inserted as part of the equation. And so if I change that value, it will change the value of the equation. Anyway, so I just recreated this equation here in the cell. And so now if I change my volt values, 0.1, I get 0.1. If I go 0.5, I get 1, like this here, right? If I do 2, I'm going to get 10, or close to 10. I'm sorry, close to 100, which is, if you look over at our chart, that's accurate. Here's 2, close to 100. If I put in 3, it should be around 1,000, because we can see in the chart that's what it is, and it's also what we have. It's our data, and so it's a pretty accurate conversion. Also notice that I went ahead and I did an if statement in Excel that allows me to output the text names that I've set for these different ranges of volts and lux. And so that's what you'd want to do in your IDE, in your Arduino sketch, is create a range. So here it's what are we doing? We're between 0 and 0.5 maybe, and this one for night, and we're between 0.5 and 0.75 for sunrise, sunset, whatever. And then you'll see that this changes with my as I change my inputs in voltage. Oops. Okay, So what's the summary here? Let me go ahead and make this back the way I want it to look. We have a sensor that we use it in a circuit. It's called a voltage divider circuit. We apply a voltage, and which has a known value. We have a resistor of a known resistance, and then we get an output voltage from that circuit, and that output voltage varies based on the amount of light hitting our sensor. Really cool. But volts doesn't tell us anything understandable about light levels, so we have to convert it either to lux or to a description, and we do that by doing an experiment like this here in different situations, and then coming into Excel, getting an equation for the trend line for that data set, and then use it to output lux values and text descriptions based on the voltage inputs. I did that in Excel. You should be able to do the same thing in the IDE. It's all just math. Excel is it's a math inputting, it's a calculator, and and you can also use your IDE as a calculator essentially. Okay, I hope that helped. As always, make sure to ask me questions. All right.